x cubed. What's next? It's going to be x squared, x, and 1 anyway. And it's going to be 3, 3. That's going to be minus, that's going to be plus, that's going to be minus, yes. 1, 3, 3, 1. Every second one's going to be negative from this negative here, all the...
Okay, I got it. You actually expanded that one out.
Okay, so I expanded that one out. That's not so bad, because it was quick. You can do a cube. There's no fancy coefficients or anything like that, so that's all right. But now I don't want to expand this all out. I don't want to be like Dylan. I want to be sensible and just need the terms that we need. Okay, yeah, it's the NCR thing, but we need to figure out which ones we need. And which ones do we need? Well, they're all going to be multiplied by these terms. And at the end of it, I want terms that have x to the power 0 or nothing, or no x with them. Yeah.
So all the powers have to add up to 0.
Yeah, so there's going to be a couple of ways that this is going to work, isn't it? If 1 is multiplied by a constant term here, that will be a constant. Yes? But if this is multiplied by 1 over x, it's a constant. If this is multiplied by 1 over x squared, and if this is multiplied by 1 over x cubed, they could be constants as well. So we need to check, is there a constant in here? Is there 1 over x in here? Is there 1 over x, or not 1 over, just x squared and x cubed? So if I multiply this by that, what do I get? Yeah, I get a constant. Yeah, it mightn't be 1 over, it might be 7 over or whatever, but it gives a constant because the x cubes cancel. Okay, so this is where I'm looking for. I'm looking for all these, if they are present or not. And this, well, this is where I look at the general term of this. I go, right, it's going to be 6 choose something. The first term is 1 over 2x squared. Sometimes I put a box here. 4x is here. Put a box here. And I think about all the powers that add up to 6 and what they give.
Write that down as 2x to the 1 over 2 times x negative 2.
No, not necessary.
No? Is that first thing, sir? I feel like it makes
6.
it different.
Okay, so you want them to cancel each other out. So we just go through them. If this is 6 and 0, this is 12, and that, they're not going to cancel. If this is 5 and 1, that gives 10, and that's 10, and yeah, that's not one of ours. So we're down to, so you're going to go 6, 0, 5, 1, 4, 2, 3, 3, 2, 4, 1, 5, 0, 6. That one's gone, that one's gone. 4 and 2 gives an 8 here, and a 2 here. That's also not what we want. That gives us, I know, yeah. That gives, sorry. This gives us 6 here, and hold on. 3, 3. If that's 3, and that's 3, that gives 1 over x to the 6. And this gives x cubed. Combined is 1 over x cubed. Is an x cubed. So this is one we need. All right? Because that's going to multiply by... All right. So what happens if it's 3 and 3 here? This comes to x6.
Yeah, 1 by 2x.
And this comes to x cubed. Subtract those two. Because this is dividing. This is dividing, so we subtract them. And we get x to the power of negative 3. Or 1. And that's one we wanted to find. Okay, so that one is here. So that'll end up being multiplied by x cubed in a minute. Now let's do another one. So we got that one. We'll do that in a second. Another term, maybe Philaine was saying that we might have another one here. So 2, 4 gives what? 2, 4. Okay, they cancel each other out. So yeah, why is that one working? Because when that's multiplied by this constant, that's going to be a constant. This one's going to cancel. So if I have 2 here, that gives x4 below the line, and 4 here, that gives x4 above the line, they're going to cancel each other out. Going to make a constant, which multiplies by this minus 1. So therefore, that also needs to be included. All right. You can do the next ones, but I don't think any of them are required. 1 and 5 gives 5 here, 2 there. That gives positive x, or x to the positive 3, which is not one that we wanted. And the same for 0, 6. So they're not going to work either. So these are the two we need to find. This one is going to be ended up multiplied by the x cubed.
Oh, shouldn't it be 6?
And this one's going to be multiplied by the minus 1 here. Okay?
Six, 3, 6.
So 3 is here, so 3 is there. 4 is here, so 4 is here. You can pick the 2 either, but same. And then we just need to work out each of these.
That's what a calculator is for.
Yep, so 6 choose 3 can be done on the calculator. I think it is 20? 6 NCR 3. 6 NCR on the calculator 3. And 6 NCR 4. So 6 things, you want to choose 3 of them. We can get... This is 15? Okay. This one's 15. This one's 20, isn't it? Okay. So it's a bit messy looking now. I know that. So, but this is 20. 1 over this cubed is going to be 1 over 8. I'm ignoring the x squareds because I know already what the x's are going to do. So I don't even need to do that. But what's 4 to the power of 3?
64.
Boom. 64. Okay. And that's going to be multiplied by an x. So that's just a 1 coefficient. So this is the multiplication I need to do. And I think 8 fits into that 8 times. So 8 times 20 is 160. Now, are we absolutely sure that that's going to be positive?
Where in the world are you right now?
Yes, because it's multiplied by, multiplied by 1 over, sorry, multiplied by x to the 3.
Yeah, I'm doing this one. This one created x, 1 over x, or x cubed on the denominator. And this one is the thing I'm going to multiply it by. 8 times 20. I'm working out the coefficients. I think you need to review your binomial theorem. 6 choose 4. I'll do it again with this one anyway. So 6 choose 4 gives an answer of 15 using calculator. That's fine. Or you can use Pascal's triangle if you want. Now I'm only going to do the coefficients here because it's a half. A half squared is a quarter. And a 4 to the power of 4, that's quite a large number. 256, yes. 256, and this one multiplied by minus 1 from this constant. That's that one. Okay, so 4 fits into 256 how many times?
It will be 960 times the negative 1, so negative 960.
Negative 960, yeah, because you have a calculator anyway, but yeah. Gives negative 960. That one and that one combined make negative 800. Or negative 800, yeah. And that is the constant term.
I was just a little off.
Yeah, you were.
So apparently I got a star